What's the difference between the diameter and the radius? The radius. Do you get it? Diameter minus radius equals, you still have another radius left. So anyways, we're going to be talking about other segments in lines that intersect with circles, not just the diameter and the radius today. One of those, so when we're talking about circles, we're starting our circle unit, we need to know how to name them. And the way you name them is you use the center point. So it would be this point right here, that is at the center point, midpoint of the diameter, point A. You can write circle A, or there's also this symbol that you can use, which looks like a circle with the dot on it, and then the letter A. Now, lines can intersect circles at either 1 or 2 points. So the lines that we'll be talking about primarily today are the lines that intersect 1 or 2 points. Secants intersect a circle at 2 points. So if I was looking at this, I would say, well, okay, EF is definitely intersecting at 2 points. So EF is the secant of this circle A. Another line that intersects at 2 points is CG. Now, when I talk about secant, I'm actually talking about a line, and I mean line, that goes on forever in both directions. Now, technically, I could say line CD if I put the arrow symbol, because in theory, you can extend this segment into a line going off in both directions. So if I don't have those arrows there, this would just be a segment, which would not be a secant. All right, chords are just part of a secant. So they're the segment where the endpoints lie on the circle. So I can again use the same pieces here. One thing to note, diameters are always chords because the endpoints are always on the circle. And chords are sometimes diameters. For example, CG here is definitely a diameter, but CD is not. But both of those are chords. So again, CD is a chord, EF is a chord, neither one of those are diameters, and CG, which is a diameter, is a chord. Tangents. Now, a tangent is a line that intersects a circle at exactly 1 point called the point of tangency. So in this example here, this line BH is tangent to circle A. So you can see how it just barely touches at 1 point. Now, tangents are always perpendicular to the radius at the point of tangency. Well, let's see. Why would that be? Just to kind of talk it through, if you have the radius going to that point and this line is barely touching that point, kind of balancing on the circle, that means both these angles would have to be the same. Well, if both those angles are the same and that adds up to 180, then they both have to be right angles. So that's just a quick way to visualize why tangents are always perpendicular to the radius at that point of tangency. So in this example, I have ST is tangent to circle R, and it's at point S. And we know that SR is 28 and ST is 45. I want to find both RT and UT. Go Longhorns. Anyways, now one thing I did is I went ahead and drew in the right angle, because remember, a tangent is always perpendicular to the radius at the point of tangency. Now you can see this is a right triangle, so I can go ahead and use Pythagorean theorem to find RT. 28 squared plus 45 squared equals RT squared. Square everything out. 2809 is RT squared. Take the square root of both sides. And then I get 53 is RT. So that whole distance right there is 53. Well, I can actually find the distance of UT right here because it's just that whole thing minus a radius. So I take 53 minus 28, so UT is 25. So some things to reflect on for this section of notes. What types of lines intersect with 2 points on a circle? We were primarily talking about secants. Is a chord always, sometimes, or never a diameter? Why or why not? So remember, we found out that diameters are always chords. Chords are sometimes diameters because they don't have to go all the way across through the center. They can go through any 2 points on the circle. What kind of angle relationship does a tangent segment or line have with the radius that it intersects? Well, you should note that it is always perpendicular to the radius at the point of tangency.